All right, here we go again, boys and girls. This is lesson 4 of Unit 10. So we kind of got away a little bit from sines, cosines, and tangents, how we began, but we are definitely going to get back into it today. So let me remind you of the important features of sines, cosines, and tangents, and then we will be able to tackle this assignment pretty well. All right, so again, the first thing that I want to remind everybody about is the Pythagorean theorem. All right, so the Pythagorean theorem gets you missing lengths of things. So the two legs of these things are going to be A or B, whatever they happen to be. And so it doesn't matter which one's which. As long as one of the legs is A and the other one is B, it's all good to go. As long as that hypotenuse, the one opposite of the 90, is their C side, that's really the important piece. And so again, A squared plus B squared is equal to C squared in that sort of situation. Again, this is presented right up at the top of your formula page. Check it out. All right, so if you have any missing sides, you need to use that. All right. Speaking of 90-degree right triangles, all right, let's talk about a particular angle that we may know or not know, or whatever. Okay, let's say we're interested in this angle theta. Recall that the side opposite of the angle that you're interested in is the opposite. You know, weird how that works out. You know, the opposite side is the opposite. And the one across from the 90 degrees is always the hypotenuse. Okay, that leaves the other one to be the adjacent. Now again, this goes without saying, is make sure you are looking at the proper angle. Like, so for instance, if I draw somewhat of an identical triangle to this, but let's say that I was talking about this top angle right here. That's my theta on top there. All right. So the opposite isn't always the right, you know, it's nothing like that. It's just whatever theta that you're talking about. So here, the opposite would be technically the bottom. Okay, the hypotenuse is still the slant side, and then the other one would be the adjacent. Okay, so you really have to be able to identify where the heck your theta is in this particular case. All right, how are the problems today going to be looking, and what do you need to know to accomplish today's stuff? All right, here's what you need to know. Quadrants. Okay, quadrants. This is technically quadrant 1, this is quadrant 2, this is quadrant 3, and the last one is quadrant 4. All right? In these quadrants, okay, let's say we have an angle in quadrant 2. All right, what kind of picture are you going to create when they give you an angle, quote unquote, angle in quadrant 2? All right, what you do is this. Okay, it goes through this origin, and quadrant 2 is going to be over here roughly. So I just draw a very generic line into quadrant 2, and then you go straight down. So this is your angle, and this is the theta in question. It's always the one right onto the origin. So go right down to the x-axis. So if it's in quadrant 1, this is what it looks like. This is your theta. If it's in quadrant 3, this is your picture right here. This is theta. And if it's in quadrant 4, here's your picture. Again, straight. This is your theta. It's one of those. That's what we're talking about. Last but not least, what are the signs of your answers? Okay, and I'm kind of getting a little bit ahead of myself like this. All right, sign. If I have a sign and I'm figuring out the answer to a sign, signs are kind of like y-coordinates. So they're positives above and negatives below. Okay, again, all of this is on the formula sheet. Literally take a look at it. Cosines. Cosines are kind of like x-coordinates of things. So cosines. So positives would be to the right, negatives would be to the left. And last but not least, tangents. Tangents are technically sine over cosine. So that means it'll be positives to the upper right and lower left, and then negatives on the other. All right. Why the heck am I bringing all of this up, and what does it have to do with today's stuff? All right. The last thing that you need to know, again, is so... hold on. Okay. All right, the best way to learn these problems is to actually do them, so let's go ahead and take a look. Given that tangent of theta is equal to 2 in quadrant 1, what is the cosine of theta? All right, so what I'm going to do is I'm going to focus in right here first and foremost. So quadrant 1. So quadrant 1, quadrant 1. Okay, tangent is equal to the opposite over the adjacent. All right, so if they say tangent is equal to 2, that's aka 2 over 1. So that means of my angle, my tangent is saying that the opposite is 2 and the adjacent is 1. So I fill in that given information. What I do from this point is I Pythagorean theorem the missing side. I Pythagorean theorem the missing side. Okay? So that means a squared plus b squared is equal to c squared. All right, so this missing side is the square root of 5. Last but not least is to answer the question that is being asked. The question is, what is the cosine? So the cosine of my angle, again, I'll help you out, is the adjacent over the hypotenuse. So in this particular case, that would be 1 over square root 5. Okay, we don't leave roots in the bottom, so we move the root to the top, get rid of this symbol on bottom. So the answer straight up is square root 5 over 5. Now, before you skip away gleefully thinking that you have the correct answer, this is when you need to think about, well, what is the proper sign of the cosine in quadrant 1? So a cosine is positive, positive, negative, negative as such. So if this is all taking place in quadrant 1, that ultimately means that my answer is indeed positive, and that would be my answer. Okay, so here we go, quadrant 4. Sine is opposite over hypotenuse, so 5 over 13. Don't worry about the negative sign, don't worry about it. Just look at the 5 and the 13, opposite over hypotenuse. Okay, find the missing side. So a squared plus b squared is equal to c squared. Okay, find your missing side. So this is going to be what? 13 squared minus 5 squared. $144. So b is going to be equal to the square root of 144, or aka 12. Okay, so we find that missing. Here we are talking about the cosine. So the cosine is the adjacent over the hypotenuse. Keep in mind that cosines positive, positive, negative, negative as such, this is all transpiring in the fourth quadrant, so the answer is indeed positive. Solve for k. Okay, which trigonometric functions could solve for k? All right, okay, so the k is the opposite. 13 is the hypotenuse, and the adjacent. So I'm just going to set it up. So what would be the sine of the angle? The sine would be opposite over hypotenuse. Cosine would be the adjacent over the hypotenuse. And the tangent would be the opposite over the adjacent. So which ones would have the ability to solve for k? Any ones that literally have k in it? All right, here we go. Quadrant 4. Opposite, hypotenuse. Let's solve for the missing side. I don't think that is anything good. Something might come out of it. Let's check that quickmath.com. So here we have the root of 119, I think it was. Yeah, 119 is 119. I think that's what it was. Yeah. So this is just the root of 119, as good as it goes. All right, we are figuring out the cosine, which is the adjacent over the hypotenuse, and it's positive in that quadrant, so that's our answer. The answer is positive. If the answer were negative, all I would do is I would just slap on a negative to the answer. That's literally the only difference. If the answer would happen to take place in where that answer should be a negative. I'll just make sure the answer is negative. All right, so here we go. Let's press on. Number 5. Okay, anything that they don't present as a fraction, you can make into a fraction. So this is just over 1 in essence. All right, so this is taking place in quadrant 2. So the tangent is the opposite over the adjacent. All right, so find the missing side. So that's the square root of 3 squared plus 1 squared is equal to c squared. So c squared, 3 plus 1 is 4. C is equal to 2. Okay. Down to it, they're asking what is the sine. So the sine is the opposite over the hypotenuse. So square root of 3 over 2. In quadrant 2, sine is a positive, so that is positive. There you go. Okay, quadrant 1, where everything is positive. Cosine is adjacent over hypotenuse. So a squared plus b squared is equal to c squared. So b squared is 49 minus 1. So b is equal to the square root of 48. Let's use quick math on this one. 4 root 3. Okay, 4 root 3. All right, so that means the tangent is the opposite over the adjacent. This is just straight up 4 root 3. It's positive in quadrant 1. Positive. Okay, quadrant 2. Okay, cosine is the adjacent over the hypotenuse. Pythagorean theorem. So a squared, so that's just going to be 5, plus b squared is equal to c squared. It's 49, so 49 minus 5 is 44. So b is equal to the square root of 44, and so that is what, 2 root 11. So the ultimate question is, what is the sine? So the sine is the opposite over the hypotenuse. Sine is positive in quadrant 2, so that's positive. Okay, again, if they don't give you a fraction, you can turn it into a fraction. This is taking place in, again, quadrant 2. So tangent is opposite over adjacent. So a squared, so that's going to be 3. B squared, that's going to be 1. So this is 3 plus 1. It's going to be equal to c squared. So c squared is equal to 4. C is ultimately equal to 2. Okay, they want to know what is the sine. So the sine of my angle is the opposite over the hypotenuse. Sine is positive in quadrant 2. That's as good as it gets. Quadrant 3. Okay, tangent is opposite over adjacent. So a squared, b squared, c squared. So 25 plus 36. Is 61. Square root 61. Square root 61. As good as it gets. Okay, so the cosine is the adjacent over the hypotenuse. Okay, is the adjacent over the hypotenuse. All right, so here when I have a root on bottom, I move it to the top and get rid of the symbol on bottom. So that's 6 root 61 over 61. Nothing simplifies. And then cosine in quadrant 3. So again, quadrant 3, a cosine is positive, positive, negative, negative. So in quadrant 3, cosines are negative. So this answer is what we have, but it's going to just be negative. Okay, last but not least, number 10. Okay, this is taking place in quadrant 2. Sine is opposite over hypotenuse. Pythagorean theorem. So 25 minus 4. Get any better than that. Ultimately, the question is, what is the tangent? The tangent is the opposite over the adjacent. All right, root on bottom, move it to the top. Get rid of the root symbol on the bottom. And tangent is negative in quadrant 2. Tangent is negative in quadrant 2. So the answer is negative.